Hello guys, today we're going to be looking at a fully automated auto brewer designed by me. Now, there is a problem with auto brewers, and there's actually quite a couple of them, but I'm going to list out four in particular, and I'll put examples of them on screen. The first one is manual inputs required, like clicking buttons to make the next stage of the process go by. It might require manually filling up brewing stands, which the hitboxes of brewing stands is not that big, which makes it quite counterintuitive. The next thing is it can often break if it runs out of materials, and it has no way of knowing that it has run out of materials. And the fourth and final problem is that some of them are just counterintuitive, like which materials go where. So today I want to be showing you my fully automated auto brewer design. And so there are some things that this design incorporates. First one, it automatically stops if it runs out of any of the materials. You can see the comparators right here, and these just detect if it has run out of any of the materials. It also detects if we've run out of water bottles and stops it if it has run out of water bottles. And on top of that, if the storage ever fills up, it will also stop if the storage fills up. On top of it, it will automatically start back up once you solve the solution. And it shares all the water bottles between all the different systems. So you can just have one massive storage of water bottles, and they'll be shared between all of the machines. It is a really simple and intuitive design. You have your storage down here with a lamp telling you if you have the materials. And then up here, you have one for your first item, one chest for your second item, and one chest for your third item. The next thing I want to look at is basically how does this work. We're going to start at the bottom. At the bottom, you have these three double chests next to these three hoppers. And this is the storage system. Basically, when the potions are finished, they're going to go down into these double chests to be stored. Up right here, you have these three hoppers, which this is the water line. Basically, I'll have a bunch of water bottles going across it to feed it into the brewing stand. And these hoppers below take it from the water line and push it into the brewing stand. Above the hopper, we have this tower of alternating between hoppers and chests. This tower in the center, that basically just brings all of the ingredients down. And then to the side, we have a dropper next to four hoppers, which lead this chest all the way to this dropper. And so that's the ingredient line, and we have three of those. Theoretically, if you wanted to, you could actually remove one of the ingredient lines and just, or maybe add another one if you have more complicated potions. So it's up to you what type of potions you want to create, right? If you want to create one that's with four ingredients, it's pretty easy to do. There's not much more wiring that needs to be done. But next, we're going to look at the stop line. Basically, this line right here that you see basically tells the system whether it's stopped or not. And this system right here doesn't have any items in the droppers, so the stop line is on. And as you can see, that powers this, which turns this light off, meaning that it's stopped, something needs to be put in. And so you can see that all of these hoppers, if there's nothing in them, it turns on the torch at the back. And then the same thing goes for this hopper, or this comparator, excuse me, that checks whether this hopper has water bottles in it. And also this hopper, which checks whether the storage system is full. And all of that ultimately ends up right here. On top of that, I'll quickly zoom back over to this one, but this also is where the timer comes in, right? The timer is down here and powers this line so that it doesn't repeatedly try to create a potion while it's brewing another potion. The last mock-up, the teardown that we'll look at, is this execution line. So if we grab a torch and we power it, we'll see that it creates a clock cycle right here. It'll turn on and then turn off and then turn on and then turn off. And so that's the kind of clock that's built into it. And then that clock, what it does is it unlocks this hopper right here so that the potions from the brewing stand go into the chest, and it also blocks this one, so water can't get into the chest. And on top of that, then it pulses, turns all of these torches on so that all of the droppers drop items into the center ingredient line. Editor Ezra here. I realize I didn't really recap the video, so I'm just going to quickly recap the video IRL. So one of the big things, it's fully automated. It can automate the materials and the water bottles. So if it runs out of either, it will stop and it will light up a lamp. It will also stop if the storage is full, which is another cool feature. But it doesn't automate everything. Now, this is kind of what I forgot to include. It doesn't automate the blaze powder in the potion brewer, which isn't actually the biggest problem, because around 3 blaze powder is approximately 1 double chest. So if you put 64 blaze powder in, you get around 21 full double chests of potions, which will approximately fill up the system about 7 times. So as long as you go in and replace the blaze powder every so often, you should be good, which is pretty good. Some of the main features of it is it shares the water bottles between the machines and is fully tileable so that you can put machines right next to each other. The complexity actually isn't that big. It is quite a big machine compared to some other auto brewers, but in terms of complexity, it really isn't that bad. I would put it right above the material cost of a regular, like the simplest auto brewer design that's still automatic. The complexity doesn't compare to some of Razeworks designs or some by Shulker Craft. So it's not a super complex design. The only complicated material is that one slime ball, but I am trying to work on a version that doesn't require a sticky piston.